All right, mineral identification. We'll start with number one. Number one is magnetic. It's metallic. Has a very high specific gravity, 5.18. Hardness of 6. It is a fractured mineral. There's no cleavage on this mineral. Number two has good cleavage at 60, 120. This is often referred to as dark black, woody or fibrous look to it. 5.8 on the specific gravity. Number three directions of cleavage, 60, 120 cleavage. This reacts to acid only on a broken surface. So it reacts to acid on a broken surface. Hardness on this one's only a 3. Specific gravity is only like a 2.7. Number 4 is a greenish color that has good cleavage on one direction. Greenish dark color. Hardness is 5. Specific gravity 3.5. That's number 4. Number 5, very soft, very dull. Sometimes the descriptors tell this mineral as having cleavage, but it is rarely to see any cleavage on it. So it's soft, dull, hardness of a 2. Moving down to number 6, we have two number 6s. We have a very shiny one, so both of these are in the mica family. There are different varieties of mica, so they have perfect cleavage in one direction, a nice flat cleavage. The silver has a different name than the black one. The black one is black because it has iron in it. The silver one is silver because it has aluminum in it. Perfect cleavage, very soft, on the hardness scale, a 2. Number 7, I'm just going to tell you what this guy is, gal, whatever it is. It's sulfur. This is what we put in fireworks. Has a rotten egg smell. Number 8 is metallic. This does not have cleavage, but it has good crystals that grow. This will fracture, so don't mix up the crystals. It has a 5.6 specific gravity, very high specific gravity, very metallic, and it's about a 5 on the hardness scale, so it is fairly hard. Number 9, instant reaction to hydrochloric acid. This is 60, 120 cleavage, 3 good directions of cleavage. Instant reaction to acid. Amazing how this mineral reacts to acid. It's a very important mineral because this follows us all the way to metamorphic rocks. Number 10, this mineral will form in almost any color. Generally has 3, even sometimes 4 directions of cleavage. You can find this on the dark mineral chart with cleavage and also the light chart with cleavage, because this mineral can be clear, it can be purple, yellow, lots of variety with this mineral with respect to color. Okay, so now we're moving on to number 11. So number 11, this one here, the diagnostic feature for this mineral here, it is metallic and it's also non-metallic, so it's listed twice as a metallic and a non-metallic. It writes on paper and has a very oily feel. Number 12, olive green color, granular in this case, and definitely it often is granular, even though in the descriptors in a lot of mineral books it tells you that this often has crystal forms. It's really rare. In fact, the crystal forms actually form gems, so we're not going to see something like this. Olive green color, it definitely is fractured, conchoidal fracture. Number 13, this has a soapy feel to it, so if you rub it on your hands, it feels like soap, and actually makes soap out of this. So number 13, soft soapy feel, very soft mineral, a 1.0 on the hardness scale. This next mineral, number 14, look at the cleavage on this one. So definitely 3 directions of cleavage. This has a salty taste. I don't know what else to say about it. Cubic. And then number 15. This mineral has striations on it. You can see the striations in the light. The darker one definitely shows the striations. Those striations look like a laser cut these striations or something, but this is actually growth lines along the internal axis of the crystal structure. This one here also has striations, although they're a little more difficult to see because of the light color. So number 15 can be either a light colored mineral or it could be a pretty dark colored mineral. Now going to number 16. This is the heaviest mineral that we have. Very high specific gravity. Metallic. It does have cleavage. It's cubic cleavage. Has a nice silver look to it. The highest specific gravity number you'll find in the charts. Number 17. What gives this one here away, it's a metallic mineral also, but one of the diagnostic features that gives this mineral away is right here. It has a red-brown streak on a streak plate. So very distinctive red-brown streak. Number 18 can vary in color. It can be yellow. Has a rust look here. Earthy. Hardness on this is about a 4.5. Number 19. This has growth lines that people often refer to as striations, but they're not because they touch one another. So number 19 has really good cleavage. Two different directions of cleavage. Nice salmon pink color here. This mineral can also be white and it can also be green. Hardness on this is a 6.5, so it's pretty hard, and the cleavage angle is at 90 degrees. Number 20. This is where the color basically names the mineral. So color is really important here. This mineral does form hexagonal prisms, but it does not have cleavage. It does form crystals, but those crystals will fracture. So that is basically, and this mineral here is actually named in accordance with the color. So color is really important with this mineral. A little more I can tell you about number 20. Hardness is a 7, right at a 7. It does form hexagonal prisms, conchoidal fracture, and we're going to go over this in lecture and why the name of this mineral has to do with the color. Number 21. This is a repeat. So this mineral forms nice little hexagonal prisms, has a hardness of 7. It is a fractured mineral, and it's one of the basic rock-forming minerals. Number 22. This is also a repeat, but this is a real beautiful form of this. These are octahedrals, so this is a good example of 4 different directions of cleavage, forming these nice little octahedrals. So this is a repeat. Number 23 is a new mineral. We haven't seen this one yet. This too forms nice little hexagonal prisms. They're small here. Has a hardness though. This is what gives this mineral away. The hardness of number 23 is a 9.0. So this is a very hard mineral, hexagonal. It can be brown, pink, blue. Number 24 forms the crystal form Dodectohedrons. These are also used as gems. The color can vary from red to green to black. Hardness on this is a 6.5 to a 7.5, depending on the chemical makeup. The ones with iron in them are a little bit more hard. Number 25, pretty straightforward here. This one forms nature's perfect shape. It forms a cube. And this is a natural occurring cube. It has not been cut, altered, polished. It is naturally occurring. And this is the preferred shape, Vitreous Lobster. Definitely that brassy yellow color, yellow gold look to it. And this is also a repeat, so we've seen this. And then number 26 is also a repeat. This little crystal form is really a good crystal form. This is what we call rhombic cleavage. Some people call it rhombohedral or rhombic. It reacts to acid instantly. So I've gone through and given you descriptors of all of these minerals. And you can see they vary with regards to size, shape, color. You know, some of them are greasy. Like, I can't really tell you about greasy here. I can tell you about it, but it's something you really have to experience. And so these minerals vary. And so the descriptors that I just gave to you are descriptors right off of these charts. So these charts you're going to use, we're going to have a midterm in here where you identify minerals, kind of like we're doing now. And you'll be able to use these charts. So mark up these charts, check off on these charts. On the midterm, I will not give you any mineral that you haven't had. So I'm not going to give you some strange mineral that we have not had. So I would actually go through charts 1, 2, 3, and 4. Go ahead, make marks on them, check off, because I'm not going to, like I said, I'm not going to give you anything that we have not had in class. When we do take our midterm, it's going to be obviously open notes, open book. You'll be able to use these charts. So get used to using these charts. These charts are going to be your guide, your pathway to identifying these minerals. So our next lab next week will be to identify rocks. And we'll be identifying igneous rocks.